Let's take a look at transformers. This is a transformer here. A transformer is a ring of metal with two coils. One coil on this side, one coil on this side. What a transformer does is it takes voltage from this side and changes it to a different voltage. So if I want the voltage to go from 100 to 200 volts in my circuit, I need a transformer. It'll take the voltage from 100 volts to 200 volts. The thing about a transformer is it has to use alternating current. And I'm not going to get into an explanation of why at this point. But it has to be plugged into alternating current on this side, and it will generate alternating current with a different voltage on this side. If you hook this up to direct current, that means like a battery or a cell, what will happen is electricity won't flow in this coil. So here's my transformer. I can change the voltage from 100 volts to 200 volts, or from 10 volts to 20 volts. That's called a step-up transformer. I could also have a transformer that takes 100 volts, turns it into 50 volts. So I'm going lower, so that's a step-down transformer. And the equation that governs this is really simple. If I have 100 loops on this side and 200 loops of wire on this side, then the voltage on this side, the ratio is 2 to 1, then the voltage will be 2 to 1. If I have 20 volts here, I'll end up with 40 volts over there. If I have 100 loops on this side and 50 loops on this side has half as many loops. So the voltage on this side will actually be exactly half as much. So if I have 10 volts alternating current here, I'll have 5 volts alternating current here. Now the thing is, it's a simple ratio, but if the voltage goes up, something's got to give. So what happens is, if the voltage goes up, the current goes down. It goes in the opposite way. If I double the coils on this side to this side, the voltage will double, but the current will be cut in half. Okay? So let's take a look at my formula. The left side is called the primary. That's the one we're plugging into, and this is what we want to change it to. That's called the secondary. The ratio of the number of the primary to the number of secondary is equal to the voltage of the primary over the voltage of the secondary. But for the current, it's the opposite, right? Because as one goes up, one goes down. So it's the current of the secondary divided by the current of the primary. We also know that power equals voltage times current. In reality, a transformer changes the electricity, the voltage, but you actually lose some power. Energy is lost to heat and inefficiencies. So to keep it simple, we're just going to say it's a 100% ideal transformer, and the power on this side is equal to the power on this side. So V times I here is equal to V times I here. It brings in another formula. If I give you a transformer problem, sometimes I don't give you enough information, and you got to use that other formula, P equals VI, to make it work out. So if I know, what we should do now is maybe try a sample problem. So I'm going to erase this, and we'll try another problem. Here's our sample problem. We've got a transformer. Transformers change alternating current to alternating current. It'll increase the voltage or decrease the current depending on how it's working. I have 100 turns on the primary coil and 200 turns on the secondary. That's a simple ratio, and it may be more and more complicated ratio, but the ratio here is 2 to 1. That tells me a lot. I can already tell that if the voltage on this side is 20, the voltage on the secondary side is going to be 40 because of the ratio. But sometimes, as I said, the numbers are complicated. You have to calculate it. When I solve a transformer problem, I suggest you put a list on this side of all your primary information and all your secondary information here. That way you can see what you have very quickly and figure it out very quickly. So let's look at what numbers we have. We have 100 turns on the primary. N stands for the number of loops. The number of loops on the secondary is 200. So I guess what I'm looking for is anything I don't have. Well, I notice I've got 20 volts on the primary, and I have these two. So I can use this formula. We're going to use this part, the number, and the voltage part to figure it out. Now, as I said, we already know this is going to be 40, but let's figure it out. So what we're going to say is the number of the primary over the number of the secondary, voltage of the primary, voltage of the secondary. So I got 100 over 200 is equal to 20 over voltage of the secondary. Rearrange that, and you get voltage of the secondary is 40 volts. So this is 40 volts, and I'm going to put AC here. It's important to indicate that. Direct current, it won't work. Okay? All right, right, how do I find the current? Well, again, the ratio tells me 100 to 200, I'm doubling the voltage, so the current should be cut in half. So half of 5 is 2.5. But what I'm going to do is I'm going to say, okay, I'm going to use this part of the formula and this part of the formula. So the number of the primary over the number of the secondary is equal to the current of the secondary over the current of the primary. Remember, this is the opposite. Don't make that mistake. So we got 100 over 200 equals current in the secondary over 5. Rearrange that. Current in the secondary should be 2.5 amperes. So you can work that out. It should work out. Yeah, it should. Half of that, they're equal. Okay? Now, current in the secondary is 2.5 amperes. Let's take a look at the power. The power on this side is 100 watts, so the power on this side should also be 100 watts. That is only if the question says it's 100% ideal, efficient, perfectly efficient transformer. If not, then it's a little more complicated. You need to, well, maybe I'll make a video on it, who knows. But this is equal to this. Sometimes you get an arrangement of the question where you don't have enough information to use this formula yet. And you need something in here before you can use it. That's where this, P equals VI. So if I knew the power and I knew the voltage, I could figure out the current without using this. So you got to look at whether it's this formula or this formula. And that's basically transformers.